This is where we left off when we were talking about how white blood cells have certain properties that make them very good at their job. So white blood cells are circulating in the plasma at very low levels until they are needed. And once they're needed, they actually can clone themselves. They can be produced in larger amounts based on need of on individual need, and I guess I should retract that word clone. It's not quite cloning, but they can be put out at a larger rate with signals from the body that there's a need for it. So what we have here, just kind of to acclimate ourselves, is we have put a splinter into the finger, or the skin, I assume it's the finger, and that splinter had bacteria on it. So what this white blood cell is, one of its properties is it's attracted to certain chemicals. And I'm not saying it's attracted to bacterial chemicals, but there are cells embedded in the skin that are going to give off a signal, I need help. And it's those chemicals that the white blood cell is attracted to, the I need help chemicals. They're prostaglandins. They are local chemical signals that all cells give off. So they have this ability to migrate out. They also have this ability to have this amoeba-like movement, which can allow them to move out of the bloodstream, but also can allow them to engulf a pathogen like a bacteria and take it into itself. Neutrophils do this quite well. Can take a bacteria in, engulf it, neutralize it, or break it apart. That those granules that you have in a neutrophil have they're called defensins. These defensin granules, and neutrophils, by the way, don't live very long, and you'll see that on the next slide. But these defensins, that actually sounds like a fake word, but that actually comes out of your book, will break it apart and then put it in a vesicle that will be sent to a lysosome. Lysosome, remember, has the digestive enzymes that can really take care of the bacteria. But in breaking the bacteria apart, it no longer has the ability to have the effect in terms of causing inflammation. So phagocytosis, chemotaxis, that's the attracted to specific chemicals. These are all capacities of white blood cells, and then the ability to migrate out of the bloodstream. Here's your leukocytes, just generally. So their general function is defense, defend the body against causative agents. And each of them work slightly different, and each of them have a different time frame in terms of how long they work. So they're all part of defense, but there's a lot of pathogens out there. They do have a nucleus. Although the function of that nucleus is not what we normally think of as a nucleus. Some of them do have the ability to divide themselves, so the nucleus is important for that. Develop from stem cells in red bone marrow, and we saw that with regard to the red blood cells. We'll see it at the end of this when we do all the cells. There's an image of all the cells. They have various properties like phagocytic behavior. Normal count is about 7,000 per cubic milliliter of blood. That's not much blood, and a lot of white blood cells. But all totaled, white blood cells are only about 1% of the formed elements. One of the reasons why I have this slide on here is it did divide the white blood cells into agranular and granular. So agranular are going to be your lymphocytes, which are made up of T cells, B cells, and natural killer cells. Lymphocytes differentiate into those three different types. Monocytes, those are your agranulars. the granulars are your basophils, neutrophils, and eosinophils. Neutrophils again, and we know this is a neutrophil because of this interesting nucleus, which we call a polymorph, polymorphonuclear, which kind of gets abbreviated as a polymorph. And they don't live very long. Lifespan's only about 10 hours. They're constantly being killed off. Those defensin granules, and that's those granules that you see staining are the defensin, plus probably other ribosomes, etc. But they are what the neutrophil can do. The neutrophil is the first to show up, and when it encounters a bacteria, the neutrophil will engulf it, and that then will cause the neutrophil to go into overdrive, I guess, in terms of its respiratory, its metabolic activity. The neutrophil can produce hydrogen peroxide type agent, and that can kill the bacteria, and then, as it said, create a vesicle a vesicle that then can be sent to a lysosome for the lysosome to give it the bacteria the final blow. We think of neutrophil as the first responder. It's the first one to show up when there's a problem, the neutrophil. It'll seek out, destroy bacteria, and about 1 billion manufactured daily. And they're constantly being killed off, because these are your I guess infantrymen, unfortunately, or women, infantrymen or women. And then eosinophils, which are very interesting, and here's a nice picture of them staining the rosy purple. It's actually how they get their name, eosin, because they pick up, apparently there was a red dye that was called an eosin at one time. It's not a term I'm familiar with, that they picked that up. And they're very beneficial in allergic reactions because they release histamine, as well as, not to be confused with basophils that also release histamine, but eosinophils, they have the ability to secrete a toxin, an exotoxin. So they secrete a toxin outside of themselves, and that can be something like nitric oxide or other cytotoxic enzymes. So we think of them in with worms and flukes, which is kind of interesting, but because they secrete this chemical, it can act on a pathogen that's more than one cell. We think of bacteria as maybe one-celled organism, but there are bacteria that have more than one cell that are in the body, and that's the job of the eosinophils to secrete. They also are mediators in allergic reactions because they go to the site and control the, reduce the inflammation that's produced by mast cells and neutrophils. I don't see it in your book where they secrete, maybe they secrete an enzyme, and I don't see it in your book where they secrete histamine. I'm not sure why I put that on the slide. I'll have to say the histamine secreted by the basophil, which is this one. This is the purple staining one, it's involved in inflammatory reactions, and certainly allergic reactions are inflammatory, but we associate the eosinophils with the allergic reactions primarily. But basophils contain large amounts of histamines plus heparin are secreted by basophils. There aren't very many basophils in circulation. They can migrate to the capillary, to the damaged tissue. They discharge their granules, and the granules themselves contain the histamine and to dilate the blood vessels, and heparin to prevent blood clotting. So what you have there is a cell that can create the inflammatory process. The eosinophil actually damps down on the inflammatory process. The non-granular or agranulocytes, it's the same, different ways to say the same thing. Lymphocytes, they are also made from that precursor cell, that megacytoblast. They come out of the bone marrow, but they're not, the T cells are matured in the thymus and the spleen. And the B cells, which is your humoral immunity, are mature when they come out of the bone marrow, but they aren't really activated till they meet their foe. B cells differentiate into plasma cells, and plasma cells then synthesize your antibodies. So lymphocytes can be either T cells, B cells, or natural killer cells. T cells are considered cell-mediated immunity, and they are matured by the thymus. B cells mature into plasma cells that then create antibodies. Natural killer cells just kind of survey, they're constantly looking around, trying to find something to neutralize, and we call them natural killer cells because they'll neutralize anything that is considered non-self. These are the granular ones. These are the non-granular ones, the ones that have no grains in the cytoplasm, that won't stain. And here you have the types of lymphocytes. I didn't realize I had this image for you. Coming out of the myeloid cell, you have your stem cell, your precursor cell. You have your whole line, which is your myeloid line. That myeloid line is going to create the granulocytes as well as the red blood cell and the platelet. That's the line on the red. The red blood cell and platelet got cut off. And then you have the back to the same stem cell, you have the myeloid stem cell. That then is going to give rise to your B cell, your T cell, your natural killer cell. So this lymphocyte line, family tree, actually comes from a different precursor cell, not the mother cell, but a different line than the cell, the myeloid cell, which gives rise to the eosinophils, the basophils, neutrophils, and the red blood cells and the platelets. And then monocytes, which is the last white blood cell. Not too many monocytes. They are large. This is deceiving. They're very large. They're, I think, your book tells you about twice the size of a red blood cell. And the thing about monocytes is they circulate for about 24 hours, and then they enter the peripheral tissue and become macrophages. Macrophages are very aggressive phagocytic cells. Macrophages, they just sit there in the tissue, so they circulate for about 24 hours as monocytes, and then they move out on into the tissue and become macrophages. We will end this, we'll finish this information about blood on the next teaching time.